This is A.REI.6 Algebra Reasoning with Equations and Inequalities 6, Video 4, Solving Linear Systems by Multiplying First. Here's a new term I'd like you to write down in your journals and define. Today we are solving this linear system by multiplying. Previously, we have solved a system of equations by graphing, setting them up into slope-intercept form and graphing the two equations to find the intersection point. We've used the method called substitution. Recently, we have used addition and subtraction to eliminate one of our two variables. And today we are going to do something very similar to that in multiplying our equations by a given term and then using our idea of elimination using addition and subtraction again. So if I'm looking at these two equations and I want to eliminate either my x's or my y's, I can do some multiplication to make the terms look similar so that I can, in fact, eliminate them. I have coefficients of 5 and 3, and I have a coefficients of 2 and -4. Well, it looks like I can take the top equation and multiply the whole equation by a 2 so that it would look similar to the second equation that has the -4 on it. So let's do that. So if I were to take the entire first equation and multiply it by 2, it's going to change or alter the look. So we're going to have 2 multiplied by 5x is 10x. 2 multiplied by 2y is 4y. And 2 multiplied by 16 is 32. And I don't need to multiply the second equation by any numbers because I already see that I have some type of 4 in the second equation, and I can choose an operation to eliminate that. So let's keep it as it is. 3x minus 4y is equal to 20. And in the last video, we made a decision on whether or not we're going to add or subtract the line. I see that my 4's have opposite signs, which means I can add the line. So now we have 13x is equal to, what do we have, 52. Divide both sides by the coefficient. So we know that x is equal to 4. We're halfway there. If x is equal to 4, let's go figure out what that y variable is. And you can choose one of your equations. I'm going to choose the equation that I didn't alter. So it was just a choice. It should work in either one. It will work in either one. So we know that we have 3 multiplied by our x. Our x is 4. Subtract your 4y equals 20. And let me do some math here. All right, so we have y equaling -2. So there is the solution to the system of equations for -2. Okay, so here we have solving a linear system using multiplication with decimals. And, you know, in the past I've taught you, you have the ability to clear the decimals. We use the term clearing the decimals. You can take each of these lines and multiply by 10 because the 10th position is common in each of your lines. I tried it both ways prior to making the video. When you're multiplying them by 10, you're going to make these numbers pretty big, and I don't think there's any need for that right now. So we're going to look for a common number that can be eliminated here. And if I were to take equation 2 and multiply it by 7, we're going to be able to eliminate our x term. So you can do it either way. If you're more comfortable with getting rid of the decimals, you can clear them, but that's going to enlarge these numbers a little bit too much. So let's scoot this over. I see that I have a 4 9/10 and a 7/10, so we can take this bottom line, multiply that bottom line by a 7, and we're going to get 4 9/10 x. And then if we were to take 3 6/10 and multiply it by 7, let's come off to the side here. And multiply that by 7. We're going to have 25 2/10 y. And then we're going to have a negative, 2.2 multiplied by 7 again. And we're going to get negative 15 4/10. I'm going to erase that work here. And let's see what we have here. We're going to line up our second equation underneath it. We're going to bring that under here. And how's that going to look? 4 9/10 x plus 2 4/10 y is equal to 7 4/10. Let's choose an operation. Looks like I have common x's and they're both positive, so we're going to subtract. And let's subtract our y terms now. So we're going to borrow, and we're going to have, let's see here, 22 8/10 y, and that's going to be equal to negative 15 4/10 minus 7 4/10. We're actually going to be adding the opposite, so we're going to be putting these together. We're going to end up with negative, let's see, that's a 0. So negative 22 8/10. Divide both sides by your coefficient. 22 8/10. So y is going to equal a negative 1. All right, we're halfway there. If y is negative 1, let's go figure out what that x is. So let's choose that equation that we didn't alter, and that will be the top one. So 4 9/10 x and 2 4/10 multiplied by negative 1 is equal to, all right. So we have 4 9/10 x equaling 9 8/10. Divide both sides by your coefficient 4.9. So x should be equal to, what do we have there, 2? So x is equal to 2 and y is equal to negative 1. Okay, last one. This video is going a little long here. I promised you that we would be doing some decimals and fractions in the video. That was actually per your request. So I picked one of each, and this one we have fractions as coefficients, and then we have some whole numbers as your constants. So how are we going to work this out? I think the easiest way is to look at your denominators of each equation and then multiply by what we call a least common multiple. And the negative 3 is going to have a denominator of 1, and the 8 will have a denominator 1. So let's work with the first equation. Looking at all the denominators, I have 5, 4, and 1, and the least common multiple is the number that they all go into. That's the smallest. So 5, 4, and 1 would have to be a 20. So I'm going to take the first equation and multiply it by 20 so that I can see what happens to these fractions now. The bottom equation, I have a 5, a 3, and a 1. So let's see, that would be 15. They all go into 15. And let's see what happens to those fractions. All right, so we can do some cancellation here. 5 and 20, so that'd be 1, and 4 times 3 is 12x. And then we can cancel the 4, we get a 1. We can cancel the 20 and get a 5. So 5 multiplied by negative 3 is negative 15y. And then 20 multiplied by negative 3 over 1 is your negative 60. All right, now the bottom equation, we can do our cancellations here. 5 goes to 1, 15 goes to 3. 3 times 2x is 6x. Cancel, 3 goes into 3 once, and 5 times on the top. 5 times 1y is 5y. And 15 multiplied by 8 over 1, that's going to give you 120. And now we have these two equations, and all of our coefficients are different from each other. So now we're going to take this line and do what we did in the previous pages of this flip chart and try to use a multiplication to eliminate one of these two terms. And I'm just looking at the 6 and the 12. We can quickly multiply the bottom line by 2. All right, let's do that. So now we have 12x and we have 10y and 240. Wow. All right, let's go line these up and see if we can take care of our elimination. Come off to the side here for you. So 12x and 10y and 240. Then the top equation was 12x, negative 15y, and negative 60. What can we do to these? To eliminate our x's, looks like we're going to subtract them. So we have 10 minus a negative 15 is positive 25y. 240 minus a negative 60 is positive 300. Divide both sides by 25, so y is equal to 12. So half of our answer is complete. Let's go find the x-coordinate by substituting our 12 into, I'm going to take this unaltered first equation up here and substitute in my y. So let's take 12 times x. Oh, we don't have an x, so 12x minus 15 multiplied by 12. And that should be equal to negative 60. All right. 15 times 12, let's see, 15 times 4 is 60, and there's 3 of those, so that's negative 180, and that is equal to negative 60. Add 180 to both sides, inverse operations, so 12x is equal to, let's see, negative 60 plus 180 is positive 120. Divide both sides by 12, x is equal to 10. So now we have the solution. If I can find some room on this paper here, our solution, x is 10 and y is 12. All right, I think that's got us here. In your journal, please define the given term on page 2 of the flip chart. Write a few sentences on what you learned from this video, and we're going to bring all these notes to class. I bet there's some tough ones on there, the decimals and the fractions. Per your request, as I said, I put some of those on there. We can do some more of those together, and there's also going to be some instances where you will have to multiply both of your equations by different numbers so that you can get one of those terms eliminated. And I'll bring one of those to class too so you see what I'm talking about. All right,